Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve a paper 1 of this subject. This is a multiple choice paper, and the time allowed for this paper is 1 hour. So here we have May-June 2023 1-2 paper. The time allowed is 1 hour. So these are the instructions for the paper. If you can pause the video, you can watch this. You can read these instructions. Okay, so the question number 1 is showing up on your screen. He says, in an experiment, he says, a ball is rolled down a curved track that is about half a meter long. Which measuring device is used to measure the length accurately? Because the track which you want to measure is curved, so we can use tape measure because the tape measure is flexible. So you have to use this. So hopefully you understand. So let's check the answer. D is the right answer, sirs. Question number 1, D is the answer. Which row describes acceleration, displacement, distance, and speed? Acceleration is a vector quantity. Displacement is a vector quantity. Distance is a scalar quantity. Speed is a scalar quantity. So I think D is the choice. Question number 2, D is the choice. Question number 3 is showing up on your screen. He says, what is the size of the resultant of the two forces shown? Here we have a one force and 3 Newton, other force 4 Newton. They are making 90-degree angle. And when he represented them, he joined their tails together. So what we will do, we will complete the parallelogram. We are going to use the parallelogram law to find the resultant. So I will complete the parallelogram because this angle is 90, so this angle will be also 90 in parallelogram. This is 3 Newton, this side is also 3 Newton. So if you look at this triangle, it's a right angle triangle, and this will be its resultant. So you can apply Pythagoras also because it's a right angle triangle. You know its base and you know its perpendicular. So you can find its hypotenuse. Hypotenuse is the resultant here. So r square is equal to 3 square plus 4 square. That's r square is equal to 9 plus 16. R square is equal to 25. Take square root on both the sides and you will get 5. So the answer is 5. Answer is 5. So I think C is the choice. Let's check if question number 3, C is the choice, sir. So we are going to the next question. The next question coming up on your screen is question number 4. He says the curved line on the distance time graph shows the motion of a toy car. The straight line is the tangent to the curve at 10 seconds. Okay. So here we have a distance time graph, and in this distance time graph, you can see the distance is on the y-axis, the time is on the x-axis, and it's a curve. And on when the time is 10, there we have drawn a tangent. And you know the tangent of the distance time graph represents speed. So it says, what is the speed of the toy car at 10 seconds? So I will note down 2 points on this tangent. And once I will note down 2 points on this tangent, then I will find out the gradient of this tangent. Note down the coordinates of the 2 points on the tangent, and then I will be able to tell you what is the gradient. So suppose I take this point 0, this is 3, 0, 3, and 10, 6. So I'm taking 2 points on this tangent, and I'm going to use them. And here we have Here we have. So I have noted down 2 points, 10,6 and 0,3 on that tangent. Then I will apply the formula of the gradient, that is y2 minus y1 divided by x2 minus x1. So it will be 3 minus 6 in the numerator, 0 minus 10 in the denominator. So you will have minus 3 by minus 10, which will be 0.3 meter per second. 0.3 meter per second. So do we have these options here? 0.3 meter per second. Yes, we have this option here. A is the choice. Question number 4. Question number 4, A is the choice. Question number 4, A is the right choice, sir. Okay, question number 5. He says the diagram shows four. Question number 5. He says the diagram shows four balances W, X, Y, and Z. W is a spring balance, and X is the top pan balance, and Y is the lever arm balance, and Z is the two pan balance. The scales of all the balances are calibrated on the Earth to measure the mass. Which balances also measure mass correctly when used on the moon? These first two, the spring balance and the top pan balance, they have a spring in them. And so it basically, the extension of that spring depends upon the weight of the object hanging. So, and that weight depends upon the G value. So the G value on the Earth is different. So G value on the Mars will be different. But these two, the Y and the Z, they do not depend upon the G value. So and W and X, they will be not accurately measuring the mass on the moon or Mars. And Y and Z, they will measure this. If you measure mass with them, they will give you the same reading on the moon. So Y and Z, they will be working correctly on the moon. It's a little tricky question. So we have this D choice. So question number 5, D choice. Okay, so we are going to the next question. That is question number 6. He says a spacecraft carries a probe to Mars where the gravitational field strength is 3.7 Newton per kg. The weight of the probe on the Mars is 370 Newton. The gravitational field strength on Earth is 9.8 Newton per kg. What are the mass and the weight of the probe on the Earth? I can calculate the mass on the Mars. The W, W is equals to mg. We know the weight of the probe. We know the G value on the Mars. We can find out what is the mass. Whatever is the mass on the Mars, same will be the mass on the Earth. Then once I know the mass, then I can calculate the weight on the Earth, because that I will have use the formula W is equals to mg. And the G value of the Earth I will use. So let me show you. I've done this on the paper, question number 6. So on the Mars, W is equals to mg. Weight is 370 Newton. Mass is question. G value on the Mars is 3.7 Newton per kg. So the m will be 370 divided by 3.7. That will be 100 kg. So whatever is the mass of that object on the Mars, same is its mass on the Earth. So on Earth now I can calculate the weight. So weight is equals to W equals to mg. The W will be equals to mass is 100 kg, and the G value is 9.8 Newton per kg. So when you multiply them, you get 980 Newton. 980 Newton. So the mass will be 100 kg and 980 Newton. So I think B looks the right answer, sir. Question number 6, B is the right answer. Hopefully you understand. Question number 7. A student determines the density of a liquid. Which equipment does the student use? So if, for example, if you want to measure the density of a liquid, we need two things. We need to know how much is the mass of the liquid, and we need to know how much is the volume of the liquid. To find to measure the mass of the liquid, we need a balance. And to measure the volume of a liquid, we need measuring cylinder. So a balance and a measuring cylinder is needed. So I think B is the choice. Question number 7, I think B is the choice. Yes, that's true. Now we have question number 8. He says Newton's third law describes a pair of forces. Which row shows whether the two forces are of the same type or whether they act on the same object? You see, in the Newton pair of forces, they are action and reaction. Action and reaction are of the same kind of forces. The two types of forces are same, means the type is same, and the objects on which they act, the in the pair Newton pair of forces, both the forces act on different bodies. For example, if I throw a ball, it hit the wall, so the action will act on the wall and the reaction will be on the ball. So you see, they act on different bodies and they are same type. I think C is the best answer, sir. C, question number 8, C is the answer. I am using a cordless mouse. That's why my mouse is not that perfectly in control. So question number 8, C is the choice. Now we have question number 9 on your screen. He says the stopping distance of a car is the sum of the thinking distance and the braking distance. Which factors affect the braking distance? You see, the braking distance is the distance covered by a car after the brakes are applied. That braking distance depends upon the speed of the car, that depends upon the type of brakes, that depends upon the friction between the tire and the road. It depends upon the wet day or it's a dry day. So, condition of the road. It depends upon the condition of the road. Yes. So it depends upon the speed of the car, obviously. Yes. If your speed is more, the braking distance will be obviously more. Tiredness of the driver, no. Tiredness of the driver affects the thinking distance because the thinking distance depends upon the reaction time of the driver. So the tiredness of the driver do not affect the braking distance. It affects the thinking distance. So for speed of the car, yes. For the tiredness of the driver, the braking distance is not affected. Conditions of the road, yes, it affects the braking distance. So yes, no, yes. So I think C looks the best option to me, sir. Question number 9, C is the answer. Yes, it's true. So we are going to the next question. He says, a load extension graph for a spring is shown. So we have a graph here. On the y-axis, we have load. On the x-axis, we have extension. So until the extension and load graph is a straight line, inclined straight line, that means that the load and the extension, they are directly proportional to each other. And once, and then when it becomes curved, then it means that the extension and the load, they are no more directly proportional to each other. So up till the point where the load and the extension, they are directly proportional, and in the sense of the shape of the graph, up till the point where the graph is a straight line, inclined straight line, that point after which the graph becomes a curve, that point is called the limit of proportionality. Which point is the limit of proportionality for the spring, and what is the spring constant of the spring equals to? So the point Q is the limit of proportionality, and the spring constant is the gradient of the extension load graph. So the gradient of the PQ represents the spring constant, and the limit of proportionality is Q point. So I think let me reduce the size so you can see the whole question. So I think limit of proportionality is Q, and I think A is the answer. Okay. So I am not able to control my mouse properly. So I think A is the right answer. The limit of proportionality is Q, and the spring constant is equals to the gradient of the PQ. So I think A is the answer. Question number 10, A is the answer. So let's go to the next question. Question number 11. Okay, so now we are back again. Question number 11 is showing up on your screen. It says a uniform beam is pivoted at its midpoint. An object weighing 40 Newton is placed on the beam 20 centimeter to the left of the pivot as shown. So here we have the pivot, which is in the center of that beam. And here we have a 40 Newton weight hanging at the left side of that pivot. And it is 20 centimeter from the pivot. So this 40 Newton weight is actually producing anti-clockwise moment. So which force and position balances the system? You see, this is it is producing anti-clockwise moment. To balance it, we will need how much? We will need a clockwise moment of the same amount. Okay, so let's check. So let me show you. Okay, so we have A option is 20 Newton acting downward 40 centimeter to the right of the pivot. So if our force in downward direction is acting here, so it will produce a clockwise moment. So it has the chances to balance it. So the clockwise moment will be 20 into 40, and that will be 800 Newton centimeter. Uh, so I think this force will balance it. The 40 Newton force is producing 800 Newton centimeter moment in the anti-clockwise manner. So I think that this is going to balance it. Okay. So if you look at the B option, I have done the other calculations also. In the B, let me explain to you. B is 20 Newton acting upward 40 centimeter to the right of the pivot. If a force here will be acting in the upward direction, it will be producing an anti-clockwise moment. This moment is also anti-clockwise. So if this is anti-clockwise moment, then they will not balance each other. The C option is 50 Newton acting downward 10 centimeter to the left of the pivot. So a force here acting in the downward direction, that will produce an anti-clockwise moment. So it will not be able to balance this anti-clockwise moment. Okay. So you can see these two are anti-clockwise moments. Anti-clockwise moment, this is 800 Newton centimeter. This is 500 Newton. So these two are not going to balance it. So in this last part, he says 50 Newton acting upwards and 10 centimeter to the left. The force acting here in the upward direction, that will be able to balance, I think. But the problem is, because it is going to produce a clockwise moment, but we have to check whether the numerical value is also the same. Clockwise moment, that will be 15 to 10, that is 500 Newton centimeter. So it is not able to balance this. Okay. So only the A is the right option, because that 40 Newton force on the left side at 20 centimeters distance from the pivot, that produces anti-clockwise moment of 800 Newton centimeter. To balance it, A is the right option, clockwise moment of 800 Newton centimeter. A little tricky question. Its option is A. A is the right option. A is the right option, sir. Question number 10, question number 11. A is the right option. Okay, so now we are going to the next question, and the next question coming up on your screen is: a worker pulls a rope with a force P through a distance D in the direction of the force as shown. This causes a block of weight W to move vertically upwards through a height H. So you applied the force P and the rope has moved distance D. Their question is, how much work is done by the worker? The useful work done by the worker is this one. He has moved the weight by a vertical height of H. So the useful work is actually W into the H, but that is not given in the options. So another formula for the work done is the product of the force and the distance moved in the direction of the force. And especially he used the word how much work is done by the worker. Worker applied the force P and the rope moved in this direction a distance of D. So we can calculate the work done by the worker as P multiply D. P multiply D. So I think B is the option. Question number 12. B is the right option, sir. Yeah. Now we are going to the next question. And that next question says, a battery is connected in a circuit to light a lamp. What is the energy stored in the battery? The energy stored in the battery is chemical potential energy. Chemical potential energy. So I think A is the right choice. Question number 13, A is the right choice. Question number next is 14. What is a property of both liquids and gases? You know, the common property between both the liquids and the gases is that they do not have a definite shape. They always fill their container. That is not, they do not always fill their gas fill always its container, but the liquids, it's not necessary that they will fill their container. They are incompressible. No, gas is in the liquid is incompressible. Gas is compressible. They can flow. Yes, gas and the liquid both can flow. That is a property common to both liquid and gases. So C can be the right answer. They have particles in fixed position. No, they don't have particles in fixed position. So question number 14, C is the choice. That's true. Okay, so question number 15 is showing up on your screen. He says in an experiment, the volume of a gas in a cylinder is measured as the pressure of the gas is increased. The values obtained are shown. So here we have a gas inside a cylinder. Here we have a movable piston. When the pressure is 1 expo 5, the volume is 20 expo minus 5. When the pressure is 2 expo 5 Pascal, the volume becomes 10 expo minus 5 meter cube. When the pressure becomes 3 expo 5 Pascal, the volume of the gas becomes 6 expo minus 5. And when the pressure becomes 4 expo 5 Pascal, the volume becomes 4 expo minus 5. Okay, so here we can, you see, here, because the pressure and the volume, they have inverse relation with each other. So if you will double the pressure, the volume will become half. If you will make the pressure 3 times, the volume should become 1/3. When you will make the pressure 4 times, the volume should become 1/4. Okay, so here you can see when I made the pressure double, the volume become half. When I make the pressure 3 times, the volume has not becomes 1/1/3. So because when you divide 20 expo minus 5 with 3, it should become 6.666 expo minus 5. It has only become 6 expo minus 5. When you have made the pressure 4 times, the volume has not become 1/5. You see, when I will take 1/5 of 20 expo minus 5, it should be 5 expo minus 5. It is only 4 expo minus 5. What is, so these two are different values. They are not according to the pattern. So what is the possible explanation for these results? The volume, here the volume must have been 6.7 something, and here the volume must have been 5, but it is 4 expo minus 5. So it is less volume. So the what is the possible explanation for these results? Here I think some of the gas has leaked. Some of the gas has leaked. That's why. After the pressure is doubled, gas starts leaking into the cylinder. Yeah. After the pressure is doubled, gas starts leaking out of the cylinder. Yes, this is the right thing. The B is the right answer. The temperature of the gas is constant. Yes. But if the temperature of the gas is constant, then this should hold in all the values. That law must have been kept, that the volume and the pressure, they are inversely proportional. The temperature of the gas is increasing. No, that is not true. So if the temperature of the gas has increased, then the volume will not decrease. Okay. So after the pressure is double, gas starts leaking out of the sun. That's why this volume is not that much, which it was supposed to be. So I think B looks the right answer to me. Question number, I think this is question number 15. So 15B is the right answer, sir. Question number 15B is the right answer. It's a very tricky question. It's a brand new question. Okay, now we have question number 16 on your screen. He says, the diagram shows examples of thermal expansion. Expansion of the liquid in a thermometer, that's the P. And Q is expansion of a tight lid on a glass container. Expansion of a tight lid on a glass container. Then we have R, which is expansion of the long metal beams supporting our roof. Okay, so we have these. I hope you can see them. Yeah. So their question is, which diagram is the thermal expansion useful? In the thermometer, the thermal expansion is very useful. In the P, the thermal expansion is very useful. In the Q case, the thermal expansion is very useful because you are able to open that lid. In the case of R, it's not that useful. So I think P and the Q only, R is not that part. So I think B is the right choice. Question number 16, I think B is the right choice. Question number 16, I think B is the right choice. Question number 16, B is the right answer, sir. Okay, so we are going to the next question. The next question is question number 17. He says, which statement about copper explains why it is a better thermal conductor than glass? Atomic vibration, why the copper is a better conductor? Because in the copper, we have free electrons, which we do not have in the glass. Atomic vibration is passed on to the neighboring copper atoms slowly. No. Atoms move through the copper and pass on kinetic energy. No. There are density changes with the copper. No. There are free electrons in the copper. So I think D is the best option. D is the best option to me. Question number 17, D is the best option. Then we have question number 18. He says, which statement describes the transfer of thermal energy in a liquid by convection? You see, convection takes place due to the changes in the density. Where you are heating the liquid there becomes less dense, and that less dense rises upward. And the cold liquid, which is more dense, sinks downward. This creates convection currents. So a decrease in its density causes the heated liquid to rise. No. Sorry. Yes. A is the choice. Looks to me the best option. Free electrons carry energy large distances through the liquid. That is not convection. Infrared radiation passes through the liquid and transfer energy. This is not convection. Particles of the liquid vibrate and pass energy to the neighboring particle. This is also not convection. Convection is where the density of a liquid becomes less dense and it rises upward. A is the right answer, sir. Question number 18, A is the right answer. Question number 19, which characteristic describes the image formed by a vertical plane mirror? The image formed in the vertical plane mirror is virtual, it is upright, and it has the same size as that of the object. Its distance from the mirror is equals to the distance of the object from the mirror. So I think B is the right answer, sir. The rest of the answers are wrong. So question number 19, B is the right option, sir. Question number 20, a ray of light passes into a block of transparent material as shown. What is the refractive index of the transparent material? So here the incident ray is shown, the refracted ray is shown, but they are not shown the angle of incidence and angle of refraction. So first of all, I will draw a normal here and I will check how much is the angle of the incidence, and then I will check how much is the angle of refraction. So this angle of incidence will be 90 minus 35. This angle of refraction will be 90 minus 60. And then I will be able to tell. Okay, so here we go. You see the angle of incidence will be 90 minus 35, that is 55. The angle of I by right. Here is this word is refraction. Refraction, and that will be 90 minus 60, and that will be 30. And you know the formula for the refractive index is sine I divided by sine R. Sine I is sine I divided by sine R. So it will be sine 55 divided by sine 30. Enter this in your calculator and you will get 1.638, 1.638, which is approximately equals to 1.64. 1.64. I think C is the answer. Question number 20. C is the answer, sir. Okay, that's right. Now we are going to the question number, we have here question number 20, and it says the diagram shows light incident on the straight edge of a semicircular glass block after passing through it. Which diagram shows refraction and an angle I equals to the critical angle of the glass? You see, angle of incidence will be equal to the critical angle when the light will enter from the dense medium into the rare medium, and it will start, it will go on the boundary between the dense medium and the rare medium, and the angle of refraction will be of the 90-degree. I think C, this angle of incidence is the critical angle because here this angle is 90. The light is traveling along the boundary of the of the dense medium and the rare medium. C is the choice. Question number 21. C is the right choice, sir. Okay, so we are going to question number 20. He says which radioactive isotope can be used for measuring cracks or flaws in metal components? So whatever the radioactive isotope you should use, it should have a long half-life. So you do not have to frequently or often you have to change it. Okay, so you do not have to replace it with a new isotope. So its half-life must be long, and plus it should not be emitting alpha particles because the alpha particles will not be able to pass through the metal components. Their penetration power is very low. So we do not use that isotope which gives out alpha particles. We use that which gives out gamma rays. So it can pass through the metal and be detected by a detector on the other side of the metal. And its half-life must be long. So A option, americium 241, an alpha emitter. Alpha, no, this is not the option. Cobalt 60, a gamma emitter. This can be a half-life of 5 years. Yeah, this can be an ideal case. Radium 223, an alpha emitter. Good. With a half-life of 11 days. This is not good. 11 days is not a good option because after let's say 2, 3, 4 half-lives pass, you will have to replace it. And alpha emitter, oh sorry, he says alpha we are not going to use because the alpha is not able to penetrate through the metal, so C cannot be the answer. Barium 137, a gamma emitter. Yes, gamma rays is a good thing because they can penetrate through the metal and can be detected by a detector on the other side of the metal. Half-life of 3 minutes? No, 3 minutes is too short half-life. You see, this isotope will be consumed, decayed very quickly, and you will have to buy new. So I am looking for something whose half-life is longer and who emits gamma. So I think B can be the answer. Question number 22. B is the right option, sir. Ultrasound is a type of sound wave that is not audible to a healthy human ear. Which range of frequencies contains only ultrasounds? You know, the audible frequency range for the human ear, healthy human ear, is from 20 hertz to 20,000 hertz. And the sound waves whose frequency is more than 20,000 hertz, 20K hertz, that is ultrasound. So The right option, I think, will be the D option because it has 30 kilohertz to 30 megahertz. So that is ultrasound. D, question number 23. D is the right option, sir. Question number 24. What proves that a metal bar is a permanent magnet? The, the test for something to be magnet is repulsion. The metal bar, if it's a permanent magnet, should be repelled by another magnet. It attracts both ends of a compass needle? No. It attracts one end of another magnet? No. Attraction is not a test. Repulsion is the confirmed test. It conducts electricity? No, 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 no. It repels one end of another magnet? Yes. It should repel one end of another magnet. When it will repel, that means that this metal bar is also a magnet. So I think D is the choice. Question number 24. D is the right choice. Question number 25, he says the diagram shows a bar magnet and four labeled arrows. Which arrow shows the direction of the magnetic field at the point where the arrow is shown? Okay, the magnetic lines will be coming out of the north and going into the south. So they are going in this direction, okay? So this arrow from here, they are coming out, you know. The A is wrong, B is wrong. Here they are going in, so C is also wrong. Here, the magnetic lines will be going from north to south. And you know the magnetic compass needle always aligned itself with the magnetic lines in that region. So this magnetic compass at the point D is pointed exactly aligned with the magnetic lines in that area. So D is the right option. I think D is the right option, sir. Question number 25, D is the right option. Question number 26. He says a shoe becomes positively charged by friction when it rubs against a carpet. So your shoe has become positively charged. When something becomes positively charged by rubbing, that means it has lost electrons. What happens as the shoe becomes charged? Negative electrons are transferred to the carpet. That seems good answer. Negatively, electrons are transferred to the shoe. That is not right, sir. Because the shoe has become positively charged, so electrons have been transferred from the shoe to something. Positive electrons are transferred to the carpet. There are no positive electrons. Positive electrons are transferred to the shoe. That there are no positive electrons. So I think A looks the best option to me. Question number 26. A is the option, sir. Question number 26, we have that option. Okay. So now we are on the question number 27. He says a metal conductor is connected between the positive and negative terminals of a battery. Which row gives the direction of the movement of the particles that flow in the conductor and their name? So in the conductors, the electrons are flowing and the electrons always move from the negative terminal of the battery to the positive terminal of the battery in a circuit. So from the negative terminal to the positive terminal, and they are electrons. So I think D is the right option. Question number 27. D is the right answer, sir. Okay, so we are going to next question. The next question is 28. Three identical cells are connected in parallel to a resistor. What is the advantage of using three cells in parallel rather than using a single cell? You see, when you use three cells in parallel to each other, the load is shared by each of them and the life of each cell becomes longer. Each cell produces more energy. No, each cell supplies more charge. No, each cell takes longer to discharge. Yes, that is the answer. The EMF is greater than that of a single cell. No, the EMF of the combination is equal to the that one single cell. C is the option, sir. Question number 28. C is the right option. Question number 29 showing up on your screen. A student has three 15-ohm resistors. She connects the resistors together in different arrangements. What is the minimum resistance and what is the maximum resistance of the arrangements that the students can produce? So the minimum resistance we will get when you will connect the three resistors parallel to each other. And the maximum resistance you will get when you will connect the three resistors in series with each other. So I have done this question. So when you will connect the R's in series with each other, their equivalent resistance will be R1 plus R2 plus R3. So that will be 15 plus 15 plus 15, that is 45 ohm. So the maximum resistance can be 45 ohm. And R will be minimum when you connect the resistors in parallel to each other. So their equivalent resistance will be 1 by R equivalent equals to 1 by R plus 1 by R2 plus 1 by R3. So 1 by R equivalent will be equals to 1 by 15 plus 1 by 15 plus 1 by 15. And that will be equals to 1 by R equivalent to 3 by 15. Reciprocate both the sides and you will have R equivalent is equals to 15 divided by 3, and that will be 5 ohm. 5 ohm. 5. So the maximum resistance is 45, minimum resistance is 5 ohm. Maximum is 45 and the minimum is 5 ohm. So I think B is the right answer, sir. B is the right answer, sir. Question 29, B is the right answer. Yeah, 5 is B is the right answer, sir. So here we have question number 30. He says the circuit diagram shows a variable resistor R connected in parallel to the lower section of a potential divider. Okay. The resistance of the R increases. What happens to the 2 voltmeter readings V1 and V2? When you will increase this R2, the voltage drop here will increase and the voltage drop here will decrease. So the V2 reading should increase and the V1 reading should decrease. So I think B is the option. Okay. When you increase this, the potential drop here on this combination will increase. Then the potential drop here will decrease. R1 will decrease. R2 will increase. I think B is the right option. Let me decrease the size so you can see the whole question together. So we think that 30B is the right answer. Question number 30B is the right answer, sir. Now we have question number 31. In the question number 31, it says the power consumption of a microwave oven is 1500 watt. The cost of 1 kilowatt hour of electric energy is 24 cents. What is the cost of using the microwave oven for 10 minutes? So, you know the power, you know the time of consumption. So you can find out the electric energy used in kilowatt hours. And then you know the price of 1 kilowatt hour, just multiply it with the energy consumed and you will be able to tell the how much it costs. So here we have, let me show you. Question number 31. Energy is equals to power multiplied time. That's 1500 divided by 1000 to convert the watts into kilowatts. Multiply 10 divided by 60. Why I'm dividing with the 60? Because I'm converting the minutes into hours. So you will have 0.25 kilowatt hours. So 0.25 multiply 24 cents, you will get 6 cents. So the price for using that oven for 10 minutes will be 6 cents, I think. It was 6 cents. Yeah, it was 6 cents. 6 cents. A is the option. Question number 31. A is the right option, sir. So here we have, he says a coil of wire above a magnet is dropped. As the coil falls over the magnet, an EMF is induced across the coil. What does not affect the magnitude of the EMF induced across the coil? What does not affect the magnitude of the EMF induced across the coil? Changing the number of turns of the wire in the coil, that affects the EMF induced. Changing the height h from which the coil is dropped, I think it changes because if you drop it from a higher point, its velocity will be larger when it will be coming near the magnet. Changing the direction of the magnet as the North Pole is at the bottom, this will it will not change the EMF induced. Yes, it will not change the EMF induced by changing the direction of the magnet, the poles of the magnet, I mean. it do not affect the magnitude of the induced EMF. It changes the direction of the EMF, but it do not change the magnitude of the EMF induced. Changing the strength of the magnetic field from the magnet, yes, this affects the EMF. So I think C is the option. Question number 32. Question number 32. I think C is the option. Question number 32, C is the right option, sir. Oh, sorry. Question number 33. The results of alpha particle scattering experiment give evidence for which of the following? The alpha particle scattering experiment, which we call Martson experiment, Geiger and Martson experiment, in that they found that the atom has a nucleus. Most of the space in the atom is empty, and there is a small place at the center, which is nucleus. All the mass of that atom is in that nucleus. So the size of the nucleus, I think D is the best option, sir. Question number 33. D is the right option, sir. Question number 34. The nucleus of an isotope of cobalt is represented by the symbol cobalt 5927. What is the composition of the nucleus? You see, it has how many protons? The protons are, I think, 27. So there are basically 27 protons. And how many neutrons are there? The neutrons are 59 minus 27. So most probably this is going to 9, 2, and 32. So there are 32 neutrons in the nucleus, and there are 27 protons in the nucleus. So A looks the best option to me. Question number 34, A is the right option, sir. Question number 35. The only stable isotope of gold is Au has 79 protons and 118 neutrons in a nucleus of an atom. How many electrons are there in a metal atom of this, in a neutral atom of this isotope? You see, if the atom is neutral, then the negative and the positive charge will be same. So the number of electrons will be equal to the number of the protons. It should be 79. So I think B is the option. Question number 35, B is the option. Yeah. Then we have a sample of a radioactive isotope with a very long half-life is placed next to a detector. A sample of a radioactive isotope with a very long half-life is placed next to a detector. Sheets of different materials are inserted one at a time between the radioactive sample and the detector. The background count rate is subtracted from the readings on the detector, and the corrected count rates are recorded in the table. So the type of material, when there is no sheet inserted, the reading is 450. So thin aluminum sheet is inserted, so the count rate has dropped from 450 to 381. That means the aluminum has stopped some particles, some radiation. And the radiation which is stopped by the aluminum is beta particles. So that means the beta particles are present there. So when they inserted thin lead sheets, the reading is 285. So the particles which can, or the radiation which can pass through the lead sheet, thin lead sheet, that means it also called gamma. And thin paper sheets, when you inserted thin paper sheets, there is no change in the reading, which means there is no alpha particles, because when you put paper between the detector and the isotope, because the alpha particles penetration power is very low, so they will not be able to penetrate to the paper. But when you put thin paper between the sample and the detector, the reading has not dropped, which shows that there are no alpha particles. So when you put aluminum sheet, the reading changed, so which means beta particles. And when you put some very thin lead sheets, the reading has changed to 285. So that means there is something which can pass through the lead, also thin lead. So I think beta particles and the gamma radiation both are present there. So let me reduce the size so you can see the whole question. So I think C is the choice. Uh, Beta particles and gamma radiation only, yeah. So C looks the right option to me. Question number 36, C is the right option. Question number 37. He says, in a fission reactor, which particle causes a uranium-235 nucleus to split? In a fission reactor, we take a uranium nucleus and we bombard it with the neutron. And the uranium atom splits, uranium nucleus splits and forms the nucleus of barium and krypton. So the particle which we used, that is neutron. We bombarded the uranium with a neutron. Hi. So C is the choice. Question number 37, C is the right choice, sir. Question number 38. What is the purpose of moderator in a nuclear reactor? The purpose of the moderator in the nuclear reactor is to slow down the neutrons which are given out in the process of the nuclear fission, and the moderator slows them down, and when it slows them down, the probability of those neutrons to cause fission of other uranium atoms increases. Okay, so to absorb all the neutrons in order to stop the chain reaction, no. That to produce more neutrons in order to create a chain reaction, no. To remove thermal energy in order to control the chain reaction, no. To slow down the neutrons in order to continue the chain reaction, yes. This is the right reason. Remember this. D. Question number 38. D is the choice. Okay, question number 39 on your screen. In which region of the electromagnetic spectrum does the sun radiates the most energy? The most energy given out by the sun is obviously the heat, that is infrared. So infrared is the most energy. A choice. It's a fact. Question number 39. A is the choice. It's a fact, okay? He says, question number 40, 4 of the stages in the life cycle of a star until it becomes a red giant are shown. W. Inward force of gravitational attraction is balanced by an outward force from its center. X is the internal gravitational collapse produce an increase in the temperature. It expands. Most of the hydrogen has been converted to helium. I think, first of all, this happens. Then this happens. Then I think this happens. And then this happens. So internal gravitational collapse produces an increase in the temperature. Inward force of gravitational attraction is balanced by an outward force from its center. When most of the hydrogen has been converted to helium, it starts to expand. So I think D looks the best option to me. Question number 40, let's check. Question number 40, D is the right option, sir. Question number 40, D is the right option. So, my dear students, today we have now we have reached the end of this, paper. I have tried my best to explain you the concepts of these questions, and I hope that this video will help you. If you find this video useful, it is interesting, it is helpful to you, please share the link of this video onto your Facebook, onto your Twitter accounts, onto your Instagram, onto your TikTok, everywhere, into your WhatsApp groups, into your Google Classrooms. Share this with your class fellows, with your junior students. When you do this, this helps me to promote my channel. Also, like this video. If possible, then subscribe to my channel also. So, thank you very much, everyone. Have a good day. God bless you all.